For this next experiment, we're going to get pupils to make a capacitor. So what is a capacitor? Well, it's just two sheets of metal separated by a distance. And so we can see there we're getting about 1.15 nanofarads of capacitance. And you can say, well, what happens if I make those two plates further apart? Now with two blocks of wood, and we can see that it has dramatically gone down. And so the distance that those plates are apart, now with 3 blocks, makes a significant impact on the capacitance. And so how do we get them as close as possible? Well, we could separate them with a piece of paper. Do they need to be separated? What happens if they're just touching? Then it's not really acting like a capacitor anymore. And so if we put a piece of paper in between, like so, now we're getting a pretty reasonable capacitance. Well, what effect does area have? Well, let's have a go at changing the area. So now maybe about half the area, less than half. Oh, so area does make a difference, and as I go further and further, less and less overlapping area, my capacitance go down, so area has an impact on it. And then what about the material in between? You can try different material. Do they have to be made out of metal plates? Well, no, you can also use tin foil, and tin foil is really good to model how an actual capacitor looks. So it's one sheet of tin foil, piece of paper, and another sheet of tin foil. And the really important thing is that you have to use a big enough sheet of paper so that the sheets don't touch. So one sheet on the top, one sheet on the bottom, not touching. We just roll it up now. So we're getting about 1.34. Does rolling it up affect the capacitance? Now rolled up like a sausage. That's essentially what a capacitor is. And you're seeing, yeah, it did seem to make a bit of a difference. So I ended up having to add another sheet so that the metal wasn't touching, and then going from 0.6 rolling up to 1.3, 1.8. Yeah, there we go. So that's an intro to what affects capacitance.